Hello guys, in this question there is a car which is moving with a constant speed on the road which is shown in the figure. The normal reaction by the road on the car is NA, NB and NC at the points A, B and C respectively. So we have to find out the correct option about the normal reaction. So first of all, at point A. Now at this point A, if I draw the car, then the mg of the car would be acting in the downward direction. Normal reaction would be acting in the upward direction, as well as there would be a force which is mv square by r, centrifugal force, which would be acting in the direction of normal reaction. So for point A, I can say that NA plus mv square by RA will be equal to mg, and therefore NA will be equal to mg minus mv square by RA. Now if we see the relationship of NA and R, then we can say that if RA increases, then this mv square by R will decrease, and if this will decrease, NA will increase. So I can say that on increasing the radius of the curvature, the normal reaction will increase. Similarly, for point B, this NB will be equal to mg minus mv square by RB. So again, more is the value of RB, more will be the value of NB. Now at point C, this normal reaction NC will be equal to mg, and there will be no mv square by r acting on the car, because C is a straight track and it is not being curved. So we can say that you can see also that the curvature of B is greater than the curvature of A, and therefore the radius of A is greater than the radius of B. So if RA is greater than RB, therefore we can say that NA will be greater than NB, as well as this NC will be the highest, because there is no term apart from mg. Therefore the biggest is NC, and then NA, this is NC, and then NA, and then NB. So the correct options will be option number B as well as option number D. Thank you. In this question, there is a machine in an amusement park which is revolving in a vertical circle of radius r with a constant linear speed v, which is equal to under root of gr. Now this cage is attached, this cage is having a man of weight w, which is standing inside the cage on a weighing machine which is kept inside the cage, and this cage is always vertical. So we have to find out the correct option. The first option, the reading of his weight on the machine is same in all the positions, is absolutely incorrect, because there would be mv square by r altering the weights at the different points. Second option, the weight reading at A is greater than the weight reading at E by 2w. Now let us examine this fact, that at point A we can say that mg would be acting in the downward direction, as well as mv square by r will be acting in the downward direction, and the reading r, normal reaction, which is also the reading of the weighing machine, will be acting in the upward direction. So r will be equal to mg plus mv square by small r. Okay, so the weight of the man is already W, so mg is equal to W plus m by r into v square is rg. So again mg is equal to W, so the normal reaction at A will be 2W. So the reading of the weighing machine at point A will be 2W. Now at point E, we can say that mg is acting in the downward direction and mv square by r is acting in the upward direction. Therefore, this mv square by r is equal to mg because v is equal to under root of rg. Therefore, we can say that at this point E, the normal reaction will be 0. So the B option will be the correct one because at position A, the weight will be 2W greater than that at the position E. The weight reading at position G is equal to W. So at position G, in this sideways position, in this position, mg would be acting in the downward direction as well as r will be acting in the upward direction. But mv square by r will not alter the weight reading at this position. So rg will be equal to mg. So option number C is also correct. Now the ratio of weight reading at E to A is 0. Obviously the weight reading at E is 0 and the weight reading at A is 2W. So their ratio would be 0. The ratio of the weight reading at point A to point C will be 2. So at point A the weight reading is 2W and at point C and G the weight reading is W. So their ratio will be 2, which is also the correct option. Thank you. In this question, it is given that there is a block which is moving on a frictionless track with a velocity of 1 by 2 under root gr. Now this block will start to move on a curved track beyond point B, and finally at point C this block will break off the surface, and the breaking off means the block leaves the surface at point C. So we need to find out the correct relation for angle theta. Now at this point C, if the blocks breaks off, so R will be 0. This is the breaking off, which means the contact will be not there and the normal reaction will be 0. Now therefore the mg will be acting in the downward direction and this force will be mg cos theta, this angle will be theta, and this mg cos theta will be balanced by mv square by r. So mg cos theta is equal to mv square upon r, and mv square is equal to mgr cos theta. So this is the first equation. Now we can find out the second equation by balancing the energy, and therefore this height is h, which is equal to, h is also equal to r minus r cos theta. So h is equal to r 1 minus cos theta, and therefore this initial energy at position B is equal to the kinetic and the potential, and I am considering C as ground. So the energy at B is mgh as well as half mvb square, and the energy at C will only be half mv square, where v is the velocity of the block at point C. So this EV will be equal to EC, and therefore mgh plus half mvb square will be equal to half mv square. Now this mgh will be mg into r into 1 minus cos theta plus half Vb square will be 1 by 4 into gr, and that would be equal to half mv square. Now this is equal to mgr, and I can replace the value of mv square with this one. Now cancelling out mgr, this will be 1 minus cos theta plus 1 by 8 is equal to half, and I am replacing mv square with mgr cos theta by the equation 1. So this is mgr cos theta. So this is 9 by 8 is equal to 3 by 2. In fact, I have cancelled out this mgr. So this is cos theta by 2 only, because I have cancelled mgr. So this is cos theta by 2. So this 9 by 8 will be equal to 3 by 2 cos theta, and therefore cos theta will be equal to 3 by 4 and theta will be equal to cos inverse 3 upon 4. So the correct option will be option number B. Now we move on the next question. Thank you. In this question, there is a block in the figure shown which is released from rest from the position A as shown in the figure, and we have to find out the maximum value of R so that this block completes the vertical circle. So let's suppose that that this block is released from this point and it has slided down to the position B, and the velocity of the block at position B will be V. So to find out V, we can directly apply the energy conservation, and the energy which is converted into the form of kinetic at position B will be mgh, that would be equal to half mv square, or directly we can use V is equal to under root of 2gh. We can use this formula also directly. So V will be equal to root of 2, g is 10, and the height is 5, which is in centimeters. So to convert that height into meters, I am writing it down as 5 by 100. So V will be equal to 1 meters per second. Now to complete the circle, this V should be at least equal to or greater than under root 5gr. So V square should be greater than or equal to 5gr, and R should be less than or equal to V square upon 5g, and V square is 1, and that 5 is 5 and g is 10. So this is 1 by 50, and this can be converted, this is in meters, so if we have to convert it in centimeters, then it would be 2 centimeters. So the correct answer will be 2 centimeters. Thank you. In this question, there is a block which is kept at the top of the hemisphere, and hemisphere is fixed and it is frictionless, and this block is being projected with some velocity from the top, and in the question number 1 it is given that if this block is projected with a velocity which is twice of u0, where u0 is under root gr, then it will land on the ground at some point P. So we need to find out the distance of that point from O, which is the distance OP. So let's suppose this block lands somewhere like that. This is the point P. So this is a simple case of projectile motion, and the time of flight, as we can see that if this is x-axis and if this is y-axis, the initial velocity in the y-axis is 0 and the initial velocity in the x-axis is 2u0, which is 2 under root gr. So the time of flight will be under root of 2r by g, which is the direct formula of time of flight, and the range, which is the distance op will be equal to time of flight into velocity vx. So it is root of 2 root of gr into under root of 2r by g. So this op will be equal to 2 root 2 into r. So the correct option will be option number D. Now for u is equal to u naught by 3, we have to find out the height from the ground at which the block will leave the contact with the hemisphere. So for this one, we are drawing the diagram again. Now this is the ground, and the velocity with which this block is being projected is u naught by 3. Now we need to find out the position where this block will leave the contact with the hemisphere. So let's suppose at this position, which is inclined at an angle of theta with the vertical, the block breaks off the surface of the hemisphere, which means now the breaking off means that the normal reaction in this position will be 0, and therefore this force will be mg cos theta, and a force of m v square by r will be acting on the block in the outward direction, provided that the normal reaction will be 0. So by equating mg cos theta with mv square by r, we can find out mv square, which is equal to mgr cos theta, as well as by applying the law of conservation of energy, we can say that initially energy was half m u naught square by 9, as well as considering this point as a ground, I am considering this as the reference point for potential energy. So half m u naught square by 9 plus m g h will be equal to half mv square. Now this is half m, this is in fact 1 by 18 m, and u naught is already equal to root gr, so it is gr plus mgh, and h will be equal to r minus mg r 1 minus cos theta, and this half mv square will be equal to mgr cos theta by 2. So cancelling out mgr, this is 1 by 18 plus 1 minus cos theta is equal to cos theta by 2. So this is 19 by 18 is equal to 3 by 2 cos theta, and therefore this cos theta will be equal to 19 by 27. So the height from the ground, which is the actual ground, this is the actual ground, So the height from the ground is being asked in the question. So this height h will be equal to r cos theta, and therefore h will be equal to r into cos theta is 19 by 27. So the correct option will be option number B. And also we have to find out its net acceleration at the instant it will leave the hemisphere. So the net acceleration A net is given by the two accelerations, which is the resultant of under root of A, in fact g sine theta, which is the tangential acceleration, as well as centripetal, which is v square by r. So A net will be equal to root of g square sine square theta plus v square by r is equal to, from this equation, this is first equation, v square by r is equal to rg. In fact, v square by r is equal to g cos theta. So it will be g square cos square theta. So A net will be equal to g, and this is very easy to understand because at this position the ball breaks off from the contact of hemisphere and it is no more in the circular trajectory. So if so this block is in the air at this position, and any object which is in the air, mid of the air, is having an acceleration g, which is the acceleration of free fall. So this can be understood simply. So the correct option for that is also option number C. Thank you. This is a question which is previously asked in National Olympiad, Physics Olympiad, and in this question there is a tube of mass capital M, and there are two balls, small balls, which just fit into the tube, and the mass of each ball is M, and these are similar balls. These balls are initially placed at the topmost point in the tube, you can see that, and they are released from this position with the initial velocity, which is 0. And it is also given that when these balls makes an angle of 60 degree with the vertical line, this is 60 degree, then this tube just breaks off from the ground. So what does it means and how does it works? Let us see. We have to find out the ratio of M and M. Let's suppose these balls reaches these positions, and to lift up the tube, we can see that some force is balancing the weight of the tube, and that force will be provided by the normal reaction of the balls. These two normal reactions, R and R, which would be same due to symmetry, this angle is 60, this angle is 60, so the total normal reaction in the upward direction will be 2r cos 60, and mg of the tube will be acting in the downward direction. So if this 2r cos 60 is being balanced by mg of the tube, or we can say that mg of the tube is balanced by this 2r cos 60, then the tube will lift up from the ground. Therefore this r will be equal to mg. Now this normal reaction is being applied on the tube by the balls, and therefore the tube has also applied this normal reaction on the balls in the opposite direction. So the normal reaction on the balls will be acting in the downward direction, like that, and this is R and this is R, and the mv square by R on the tube will be acting in the outward direction. This is mv square by small r radius. Mg cos theta, in fact this is mg cos 60, will be acting in the downward direction also. So the equation says that mv square by r will be balancing r plus mg cos 60. Now this mv square by r is equal to, this r is mg plus this is mg by 2. This is the first equation. Now the second equation will be obtained by balancing the energy, and this height, let's suppose it is h, and h will be equal to r 1 minus cos 60, and cos 60 is half, so h will be equal to r by 2. So as these balls approaches down, then the work done by mg will be mgh. That would be the source of the energy, which is half mv square for the balls, and therefore mg r by 2 is equal to half mv square. So mv square will be equal to mgr. Now this is equation number 2. Combining 1 and 2, we can say that small mg will be equal to capital Mg plus mg by 2. Therefore mg by 2 will be equal to capital Mg, and m upon m will be equal to 2. So this is the ratio which we are asked, that the mass of balls and mass of tube have a ratio of 2. Thank you. In this question, it is given that there is an external force of constant magnitude F naught, and it is being applied always in the tangential direction of the motion. So we have to find out the speed of the pendulum ball when the string becomes horizontal. So the motion of the string will be like that, and in this position the string will become horizontal. So this force is of constant magnitude and it is always acting in the tangential direction. So the work done by the force F naught will be equal to F naught into the arc length, because it is always acting in the tangential direction. So the distance with which we will multiply this will be the arc length of this 1/4 of circle, and this will be equal to pi L by 2, because L is the radius of the circle, and the perimeter of 1/4 circle is pi L by 2. So this is the work done by F naught. Now as ball is approaching in the upward direction, the work done against, or work done by the mg will be negative minus mg into height. This height is L, so it would be mgl, and negative sign shows that mg is acting in the downward direction and ball is approaching in the upward direction. So the work done by F naught as well as work done by mg is equal to change in kinetic energy. Now the kinetic energy at the lowest point was 0. It is given in the question. So work done by mg will be, work done by F naught will be F naught pi L by 2 plus work done by mg will be minus mgl, that will be equal to half m v square, and therefore v will be equal to f naught pi l by m minus 2 gl under root. This will be the velocity of the ball when it will reach that position shown. Thank you. In this question, there are two balls which are connected to the rods as shown in the figure, and we need to find out the velocity, minimum velocity v, which should be given to this middle ball, so that this system completes the vertical circle. So as we know that for the case of the rod, when the balls are connected with the rod, the velocity at the topmost point, minimum velocity at this topmost point can be 0, and therefore considering it that the ball reaches the topmost point with 0 velocity, we can apply directly the law of conservation of energy. Now we know that if we are giving a velocity v to the middle ball, then this ball will be moving with the velocity 2v, as due to the fact that this ball of mass 2m is 2l distance away from the center O, and let us suppose that if the angular velocity is omega, so omega will be equal to v upon l, and omega remains constant for all the components of the circular, for all the bodies which are moving in a same circular motion about a same center. So for this ball of mass 2m, its velocity v dash will be equal to 2l omega, and v dash will be equal to 2l into omega is v by l, so it will be equal to 2v. So the final energy of the system will be, in fact I can say that the total mechanical energy is constant. TME, total mechanical energy, which is kinetic energy plus potential energy, it is constant, and hence change in kinetic as well as change in potential will be 0, and in magnitude change in kinetic will be equal to change in potential, which means that if one energy will decrease, then other one will increase. So we can say that in the lowest position shown, the kinetic energy is highest, and in the highest position the kinetic energy is 0. So change in kinetic energy in magnitude will be half 2m into 4v square plus half m into v square. So the change in kinetic energy will be equal to 9 by 2 mv square. This cancels with this, and 4 plus 1 by 2 is 9 by 2 mv square. And the change in potential energy is equal to mg. The position of this ball will be at this height, so the distance it has moved in the upper direction will be 2l, and the position of the upper ball will be this, so the distance it has moved will be 4l. So this is mg into 2l plus 4 plus 2m into g into 4l. So it is equal to 10 mgl delta PE, this 2 plus 8. So 9 by 2 mv square is equal to 10 mgl, and therefore V is equal to under root of 20 by 9 gl, which can be written as 2 by 3 root 5 gl. So this is the minimum velocity required to be given to the middle ball so that the system completes the vertical circle. Thank you.